Good afternoon. I am Adrian Lam. Today I will talk about Bessel function. Before we go into the mathematics, let's just see some interesting facts. This is Friedrich Wilhelm Bessel. He was born in the 22nd of July, 1784. When at the age of 14, he joined a trade company as an apprentice in German. During his spare time in the company, he developed his interest in navigation and eventually led him to astronomy and mathematics. You can Google to know more about his biography. Now, let's just get back to the mathematics. This is the Bessel function. It is first defined by Daniel Bernoulli, the guy that discovered Bernoulli's principle, and then generalized by Bessel. It is one of the most important achievements in Bessel's life, and also one of the most important ODEs in the applied mathematics. This function is used to solve many classic physical problems or even quantum physical problems. There are tons of proofs and related mathematics you can find. However, as an engineer but not a mathematician, maths is our tools, so we should not dig too deep into mathematics, and knowing how to use it is the most important part. Bessel told us that when we are dealing with ODE like this, we will get the solution like this. J nu of x is the Bessel function of the first kind of order nu, and y nu of x is the Bessel function of second kind of order nu. In fluid mechanics, when we are dealing with the velocity distribution of projectile flow in a cylindrical channel, using Navier-Stokes equation in cylindrical coordinates, this equation will appear eventually. By setting A star to 0, we modify the equation into a homogeneous equation like this. When it is compared to the Bessel equation, we can find that they are similar, but when we look carefully, the coefficient of y is only a constant 1, but the flow problem is not. It seems that it is not a Bessel equation problem, but yes, it is indeed. Let's modify the Bessel equation by supposing there is some function set of x which satisfy the two rules of recurrence relations of the Bessel functions, so that we will get this equation in blue. Simply replace set nu of x by set nu of kx for some constant k, using the same relations and evaluate the equation. We will get this equation in red. This time, when we compare this equation with the projectile flow problem, we can see that the projectile flow problem is indeed a Bessel equation and can be solved by the Bessel function. Meanwhile, as this modified Bessel function are evaluated at kx, so the form of the solution will be a little different. This is the form of equation Dr. Sum used in his handout. Together with the boundary condition, the projectile flow problem can be solved. I hope you find this video helpful. Thank you.